Hello students, you're welcome to this class. This is Dr. Barnes. So let's take a look at this question. Find the Fourier series expansion for the waveform shown. So this is a triangular, or it is a sawtooth kind of waveform. Okay, so when you have this kind of waveform, the first thing to identify is whether the waveform is periodic or not, if the waveform repeats itself. So here you can see that the waveform is repeating itself from here to here. Okay, from here to here is repeating itself. From here to here is repeating itself. From here to here is repeating itself. So we can find a period. So that means that from here to here is a period. From here to here is a period. From here to here is a period. The period is when the waveform repeats itself. So we can take from here to here to be a period. From here to here to be a period. From here to here to be a period. But it's always flexible. It makes our procedures more flexible for the period to be in the middle. So in that case, I am going to take from here, okay, here up to here. To be my period, okay, to be my period. In that case, what will be my period? It will be from minus pi on 2 to 3 pi on 2. My period will now be from what? Minus pi on 2 to what? 3 pi on 2. That will be what? Equals to 2 pi. Okay, so now from here, I can know my wavelength. So my wavelength, omega naught, is equals to 2 pi. Or my frequency, let me say frequency, okay, my frequency is 2 pi over t is equals to 2 pi over 2 pi, which is equals to 1. All right, so now one thing about triangular or sawtooth waveform is that we must find the equations that form our wave, okay, the equations of the lines that form our wave. So here I took here and here to be my period, here to here to be my period. So I must find the equation for the line from here to here. That is equation for the line minus pi on 2 less than what? T less than what? Pi on what? 2. That is from here to here. And then I also find from what? Here to here, because this is where I took to be my period. So here I'll use the point here, and the point here is here is supposed to be A, and here is supposed to be minus A. So the point here is going to be minus pi on 2 minus A. So I'm going to have minus pi on 2 minus A, and the point here is going to be pi on 2A. Is going to be pi on 2A. Okay, so now let me find the slope for this one. So the slope, which is m, is going to be A minus A over pi on 2 minus pi on 2, because it's changing y over changing x. y2 minus y1 over x2 minus x1. Okay, so it's going to be 2a over pi. Okay, and that makes sense because you see that our line is starting from here and it's going to here. It's ascending, so the slope has to be positive, as we have here. So the next part will be from here to here, here to here. That will be from pi on 2 less than t, let pi on 2, here is what? Pi on 2, here is what? 3 pi on 2, less than what? 3 pi on 2. Okay, so here I'm going to use the point. What is the point here? The point here is pi on 2a. So pi on 2a, and the point here is 3 pi on 2 minus a. 3 pi on 2 minus a. Okay, all right. So now to do again is now, okay, all right, so now here I must find the slope for this one. So now the slope here is going to be minus a minus a over 3 pi on 2 minus pi on 2. Okay, so that will give me minus 2a minus 2a minus so here what I can say is this is 1.5 and then this is 0.5, so it will be pi. So minus 2a over pi, and that makes sense because that our line is starting from here and then it's coming here, so it's descending. Okay, so the slope will be what? Negative, as we have here. Okay, all right. So now, having done that, let's continue from there. Okay, so continuing from there, we will write the equation. We will write the equation. Okay, we will write the equation. So now, writing the equation, we're going to have f of t. Okay, we're going to write the equations. So now let me write the equations for the first slope. Okay, so let me call this one. So this is the first slope. Let me write the equation for this one. After that, I'll write the equation for this slope also. Okay, so here for the first slope, I'm going to have f of t minus. So for the first slope, I'll take this point. Okay, minus pi on 2 and then minus a. Okay, so minus the y component, which is minus a, minus a is equals to the slope, which is what? 2a over pi. 2a over pi into t minus the x component, which is minus pi on what? 2. Okay, so if I do that, here will become plus, here will also become plus. Okay, so this time this will give me what? Pi. This time this one will give me 2a t over pi, and then this time this one, this will cancel this, this will cancel this. It will give me what? A. Okay, it will just give me a, so it will give me plus a. This a is positive here, to come here and then subtract, so minus what? A. So here my f of what? T is equals to 2a on pi what? T. Okay, so that is what? My f of t. Okay, so that is my f of t. So now let's say this is the first equation. So now let's go to the second equation. So now the second f of t, we will find it for this slope. Okay, so for this slope, I will have what? F of what? T minus, I will use the first point. Okay, this one, pi on 2 and then what? A. Okay, so minus the y component, which is a, is equals to 2a. Sorry, here here. So what I'm going to have is that the slope I got here is what? Minus 2a on pi. Okay, so minus 2a on what? Pi into what? T minus the x component. What is the x component here? The x component here is what? Pi on 2. Okay, minus what? Pi on 2. Okay, so now here, this is equals to, if I do this one, what I'm going to get is this one will multiply this one. Okay, this one will cancel this one. This one will cancel this one. Okay, so I'll have minus 2a over pi into what? T. Okay, and this one will cancel this one. This one will cancel this one. Okay. And then I'm going to have negative will be what? Positive. So I'm going to have plus what? A. This A is negative. It will come here to become a positive. So plus another what? A. Okay. So now my f of t in this case is going to be minus 2a over pi plus 2a, which is equals to 2a out, okay, 2a out 1 minus t on pi. Okay, so that is what I am going to get at this particular stage. All right, so now moving on from here, what I'm going to do is that I'm going to work with the normal Fourier series equation. But before I go on with that one, let us analyze our waveform. So analyzing our waveform, you can see that our waveform here, you see that this one here, this negative aspect of the wave has a negative value, and then the positive aspect here also has a positive value, which are a and minus a are not the same, but the wave is symmetry. Okay, because you can see that here and here is one symmetry, here and here is also another symmetry. So here and here they are what? Mirror images, so it's a symmetry. But here minus pi to 0 will give me minus a, 0 to pi will give me a. That means that they are not the same. So it's an odd symmetry, so it's an odd signal. Okay, if it's an odd signal, then that means that the cos aspect, or an, will be 0. Okay, so now let me write the equation for Fourier transform, which is equals to this. Okay, sorry, I must bring a naught here, a naught plus. Okay, and then here is n is equals to 1. So an cos n omega naught what? T plus bn sine n omega naught what? T. Okay, so now here what happens is that because it's an odd symmetry, an here is going to be 0. Okay, now let me see about the a naught. Okay, basically when you take this waveform also, you can see that this positive aspect is the same as the what? Negative aspect. They have the same area. This positive aspect is the same as the negative aspect. Okay, so the positive and negative, they are the same. In that case, they will cancel out. So the average value will become what? 0. Okay, so now in this case, I can say that my a naught is also equals to what? 0, because they will cancel out. So the DC component, or the average signal of this waveform, will become what? 0. Alright. So now from here I can just move on. Okay, I can just move on. So I know that Bn, okay, Bn is, let me now move on. Okay, so now I can rewrite my equation as f of t is equals to summation. Here is what? Infinity. Here n is equals to what? 1. I'll be left with only Bn sine n omega naught what? T. Okay, and I know that omega naught is what? 1. I found omega naught to be 1. Okay, so now omega naught is 1. So the equation will now become this way. Okay, it's equal to n is equals to what? Bn sine n omega naught is 1. So it will become what? Nt. Okay, so now let me find Bn. Now Bn is equals to summation. Here I can make here T naught. Here T naught plus T. Okay, into 2 over what? T into f of what? T into sine n omega naught is supposed to be what? Omega naught what? T. And this is for the, this is within the range what? T naught into what? T into what? T naught plus what? Plus T. Okay, so now here Bn is equals to, I can now bring 2 over my period, which is 2 pi, okay, into my here. Here is minus pi on 2, and here is 3 pi on what? 2, into what? F of what? T, into sine n omega naught is 1, so nt, d what? dt. Okay, here I can bring dt here. Okay, so this is what I'm going to have. Okay, so now what happens is that I must be able to insert my f of t. But you can see that my f of t, they are two, because you see that this is the first what f of t. This one is the first f of t I got. So let me call it equation what 1. And then this is the second f of t I got. So let me call it equation what 2. So now the f of t that I have, they are 2. So that means that I must break this function into 2 halves. Okay, I must break this function into 2 halves. If I am doing that, then I'm going to have bn is equals to here. I can make it 1 over what pi into here. This one is from minus pi on 2 into what? Into pi on what? 2 into the first f of t, which is what? 2a over pi into what? T, okay, sine nt, okay, plus the second aspect, which is what? Pi on 2 into what? 3 pi on what? 2. Here is going to be 1 over what? Pi into 1 into 2a into 2a, okay, which is going to be into minus 2a, okay. Please, this is 2a, all right, which is going to be into minus 2a. Please, sorry, let me rewrite this one again, okay, so that it will be more clearer for you. Okay, let me just rewrite it again. Okay, so all right, so rewriting this one, what I am saying is that I will have bn to be equals to 2 over pi will become what? 1. Will become what? 1 over pi. Okay, will become 1 over pi into minus pi over 2 into what? Pi over what? 2 into what? 2a over what? Pi what? T. Okay, into sine nt. Okay, plus 1 over what? Pi into pi on what? 2 into pi on 2 into what? 3 pi on what? 2 into the function. Okay, what is that function? Okay, into this particular function. Okay, so into what? 2a into 1 minus t over pi sine nt, okay, dt. Okay, all right, so here also you can bring dt. Okay, all right, so here that is what we are going to have here. Okay, that is what we're going to have here. So from here we can summarize our equation. Okay, so from here we can just summarize our equation. So what we can do from here is that we can do the integration of our equation. Okay, but the integration of our equation. But before I do that, let me bring some things out. Okay, so bn is equals to, I can bring 2a over pi what? Out. Okay, I can bring 2a over pi what? Out. So in that case, I'll have 2a, okay, 2a over what? Pi squared, okay, into minus pi on 2 into what? Pi on 2 into t sine nt dt plus here I can bring the same 2a out. I'll bring 2a out over what? Pi. Okay, then I'll have what? Pi on 2 into 3 pi on 2. Okay, into what? 1 minus pi on what? 1 minus t on pi. Okay, 1 minus t on pi into sine n what t dt. Okay, dt. Okay, so now when I have this one here, minus pi on 2 and pi on 2, I can divide it into 2. If I divide minus pi on 2 up to pi on 2, if I divide it into 2, I'm going to get 0 to what? Pi on 2. So this place I can divide here minus pi on 2 to pi on 2. I can divide it into 2 so that it become what? 0 to what? Pi on 2. If I do that, then I must multiply here by 2. So I'm going to get what? 4a over what? Pi squared. Okay, into t sine sine nt dt plus, okay, here I'll just maintain it. Okay, 2a over what? Pi into pi on 2 into 3 pi on 2 into 1 minus t over pi, okay, sine nt dt. Okay, so this is what I'm going to have over here. Okay, so this is what I'm going to have over here. So now what I can do is that I can now integrate my terms. Okay, I can now integrate my terms. So integrating these terms, you have to use the integration by parts, which is given by this formula: u into what? Integral v minus what? Integral u differentiation into what? V. Okay, which is given by this formula. So here you call this t to be u, and sine nt you call it to be what? V. Okay, so here I'll call 1 minus t on pi to be u, and sine nt I'll call it to be what? V. Okay, so if I do that, then here is equals to, so bn is equals to, so now here I'm going to have bn is equals to 4a. Okay, I'll have 4a over pi squared. Okay, 4a over pi squared. Okay, okay, so now here whenever you integrate sine nt, you get minus cos nt. So, and this t will remain. So I'll get minus t cos nt over what? N. Okay, whenever you integrate sine nt, you get what? Minus cos nt over n. Okay, minus cos nt over n. Okay, then here what you do is that you differentiate this one again. So if you integrate the t, you get 1, and then you integrate sine nt, you get what? Minus cos nt, and then you integrate minus cos nt again, you get what? Sine nt. In that case, the minus will make this negative positive. So I'll have plus sine nt, okay, sine nt over what? N squared. Okay, over n squared. Then what I'll have here is my limit 0 into what? Pi on 2 plus, okay, plus the next aspect. Okay, so the next aspect I'll have what? 2a over pi. So 2a over pi into here what I'm going to have is here I'll integrate this one. I will just maintain this one and integrate sine nt. In that case, I'll get minus 1 into minus 1 in, I'll get minus into bracket 1 minus t on pi. Okay, 1 minus t on pi. Okay, so this is what I have, and then I'll integrate this one. I'll have cos nt over what? N. Okay, I'll have cos nt over n. Okay, so now then the next aspect will be to differentiate this one. Here, if you differentiate 1, you get 0. If you differentiate t, you get what? Minus 1. But there's a minus here, so that minus will affect it. Okay, so in that case, this minus, I must bring it here. And then, so if that minus is going to affect it, I'm going to get minus 1 over what? Pi. Okay, minus 1 over pi. If you integrate sine nt, you get what? Minus cos nt. Then you integrate minus cos nt again, you get minus sine what? Nt. So I'll get minus sine minus sine nt. Okay, over what? It's going to be over n squared. Okay, so if you do that differentiation, that's what you're going to get. So this one is like this. Okay, so now here I can just close it and bring my limits pi on 2 and then 3 pi on 2. So now the next stage is to introduce my limits, okay? Insert my limits into the equations, okay? So inserting my limits into the equations, this is what I am going to have, okay? So here I'll have Bn is equals to 4a over pi squared into, okay, you introduce the upper limit first. So here the upper limit is pi on 2, so I'll introduce pi on 2. So if I introduce pi on 2 into here minus t, okay, what I'm going to get is that I'll get minus pi over 2n, okay, into this place. I'll get minus pi over 2n, okay, minus pi over 2n into cos n pi on 2, okay, cos n pi on 2, plus, I'll insert it here, I'll have sine n pi on 2, okay, but what happens is that n squared is also what, over there, okay, so I'm going to get, I can bring the n squared out here like this, okay, and I'll have sine n pi on 2, okay, so like this, okay. So then after that, actually I have to insert the 0 also, but if you put 0 into this minus t here, the whole thing becomes 0, and then if you put 0 here, you get what, sine 0 n, and then sine 0 is also what, 0, so this whole place also becomes 0. So in that case, this place remains like this. Then I'll come to this limit, 3 pi on 2 and then pi on 2, okay. So now let me see how those limits will go. So now if I put 3 pi on 2 here, if I put 3 pi on 2 here, I'm going to get, this one is going to be minus, okay, and then also I'm going to have, so if I put 3 pi on 2 over here, okay, so let me first write plus, okay, let me first write here plus, okay, and then bring my 2a, this one 2a on pi here, okay, 2a on pi here. So now here, if I put it over here, okay, I'm actually going to have 1 over n, 1 over 2n, okay. So if you have 1 minus 3 pi on 2 over what, pi, you're going to get 1 over here with respect to all the signs, all the positive and negative signs, okay. You're going to have 1 over what, 2n, okay, and then you're going to have cos 3n pi over what, 2, okay, minus, then you put it here also. If you put it here, you're going to have minus 1 over what, n squared pi squared, oh sorry, it's not going to be pi squared, okay. I think my pi squared is this place, it's not this place, so it's going to what, n squared what, pi, okay, n squared pi. So I'm going to have n squared pi sine 3n pi on 2, okay, 3n pi on 2. All right, so that's what I'm going to have here, okay. So that is what I'm going to have here. Okay, let me just do it this way, and then let me just do it this way. All right, so now I'm going to insert the lower limit, okay, the lower limit, which is what, pi on 2. So if I insert the lower limit, which is actually pi on 2, then what I'm going to have is, if I put pi on 2 here, I'm going to have plus 1 over 2n cos n pi on 2, okay, plus 1 over n pi sine n pi on 2. Then I'll close here. So if I put in my limits, this is what I'm going to have. Okay, this is what I'm going to have. So now from here, what we can do is that we can just simplify our equations from here, okay, because we have put in our limits, and then what we can do from here again is to just simplify our equation. Okay, so simplifying the equations, what we're going to do is that we're going to have, if I should put in this one, okay, if I have this one, okay, this one will have to multiply the whole of this one, and it also multiply the whole of this one, okay, and this one will have to multiply the whole of this one, okay, and this one, and this one, this one. Okay, so now let us see from here. Okay, so now if I multiply, in that case, I'm going to have minus 2a over n pi, minus 2a over n pi cos n pi on 2, okay, plus 4a over n squared pi squared into sine n pi on 2, okay, plus 2a over pi into here. Let me bring this one, okay, let me bring this one like this, okay, 2a on pi into 1 over 2n cos n pi on 2, okay, cos n pi on 2, okay, plus, let me show you why I'm getting cos n pi on 2. So now, let me show you something, okay. So you see that here I have cos 3 n pi on 2. But here I am writing cos n pi on 2. Let me show you why. So this is our cos wave. So here is 1 and here is 0. So the cos wave is always like this. Okay, so here is what? Pi on 2. And then here is 0, here is pi on 2, here is what? Pi. So here is what? 2 pi. Here is what? 3 pi on what? 2. So you see that 3 pi on 2 and then pi on 2 on the cos wave, on the cosine wave, okay, or on the cosine signal, okay, on the cosine wave, the values are the same. 3 pi on 2 has 0, pi on 2 has 0. So that is why instead of writing cos 3 n pi on 2, I am able to write what? Cos what? Pi on 2. Okay, so because cos 3 pi on 2 and cos pi on 2, they have the same value. So you see that cos 3 pi on 2 and cos pi on 2, they have the same what? Value. Okay, so now moving on from here, I am going to, let me also show you something again. So you see that this is a sine wave. So the sine wave is like this. Okay, so this is sine what? 0. This is sine what? So here is what? Sine wave. Okay, sine pi on 2. This is sine what? Pi. This is sine what? 3 pi on what? 2. Okay, so what is the value for sine 3 pi on 2? Here is what? 1. Here is minus what? 1. So what's the value for sine 3 pi on 2? Minus 1. What's the value for sine pi on 2? Is what? 1. Okay, you also do that substitution. So now here, what I'm going to have is, I'm going to have plus 1 over n squared pi, okay, into sine n pi on what? 2, okay, plus sine n pi on 2. Why am I actually saying that? Because you see that here I have sine 3, I have sine what? Sine 3 n pi on 2. But here I am writing sine n pi on 2 because they have the same value. Because sine 3 pi on 2 is what? Is minus 1, and sine pi on 2 is what? 1. So that means that negative, that means that sine 3 pi on 2 is equal to what? Negative sine pi on 2. Okay, so it's equal to negative sine pi on 2. So the negative sine pi on 2, and then there's another negative here. So it will become what? Positive. So that is how come I'm having positive what? Sine n pi on 2. Okay, so that is why I'm having that. Okay, so I'm going to have 1 plus 1 over what? 2n cos n pi on 2. Okay, plus 1 over n squared pi, okay, sine n pi on 2. Okay, sine n pi on what? On 2. Okay, so this is what I am going to actually have. Okay, this is what I'm actually going to have. So now from here, what I'm going to do is I'm just going to simplify my equations. Okay, so if I am simplifying my equations, what you can see right now is that, let me see if I can have some similarities, but let me just go on. So now here I'm going to have minus 2a. I'll have minus 2a over n pi. I'll have minus 2a over n pi cos n pi on 2, cos n pi on 2, plus 4a over n squared pi squared sine n pi on 2. Okay, sine n pi on 2. Okay, plus I'm going to have 2a over n pi into cos n pi on 2. Okay, plus cos n pi on 2. Okay, so then I can continue. Okay, so if I continue, I'm going to have plus 4a over n squared pi squared sine n pi on what? 2. Okay, so why am I having these things? Okay, why am I having these things? Okay, so now what you can see is that this one and this one, they are the same. Okay, 1 over 2n cos n pi over 2, 1 over 2n cos n pi on 2. So when I add this one and this one, that is what is giving me 2a over n pi, okay, by multiplying it by this one. Okay, cos n pi on what? On 2. Okay, so you see that this one, basically I'm just maintaining this one, and then this one I am just maintaining this one I'm just maintaining here, this one I'm just maintaining here, this one I'm adding this one to this one. Okay, and then also what am I adding again? Okay, I'm also adding this one and this one, this one and this one. So if I add this one and this one, it is also giving me what I have over here. Okay, it's also giving me what I have here. All right, so let's move on from here. Okay, let's move on from here. So if we move on from here, what I'm going to have is going to be, let me see if I can have some more similarities. So what you can see is that this one and this one, they can cancel each other. They can cancel each other, and then I can add this and this one. Okay, so in that case, I'm going to have bn is equal to what? 8a over what? N squared what? Pi squared sine n pi over what? 2. Okay, so that is what I'm going to have. I think I have to tell you something here. You see that here, 2a over pi. Okay, when you multiply 2a over pi by 1 over n squared pi, you're going to get, you're going to have what we have here, n squared into what? Pi squared. Okay, you're going to have n squared into pi squared. And why is it 4a here? Okay, but because here is 2a. Why does it become 4a here? Because we are adding this one and then this one. Okay, this one and this one. So here too, if you multiply 2a over pi over n squared pi, you're going to get what? 4a into n squared into what? Pi squared when you add it to this one. Alright, so that is why. So this becomes what? Our Pn. So now our f of what? T, which is the Fourier series, is going to be what? Summation into infinity into is equals to what? 1 into what? 8a over what? N squared what? Pi squared into what? Sine what? N what? Pi over what? 2. This is what we're going to what? Get into what? Sine what? Nt. Okay, into sine nt. Okay, into sine nt. So this is what we're going to have. Now, if we have this one, now we can go on with our expansion. Okay, our expansion. So the expansion, I can bring 8a into what? Pi squared here because they are constant. And then I can have here like this. And then I can have here 1 over what? N squared. Okay, 1 over n squared into sine what? Into sine n pi over what? 2 into what? Sine what? Nt. Okay, so here, if I put in 1 into this equation, okay, so before I can even write what? 8a over what? Pi squared into, let me put 1 in the equation. What is, if I put in 1, I'll get what? Sine what? N pi. What is sine n pi? You can just take the sine, sine n pi. Sine n pi, the value is what? 1. Okay, the value is 1. So that means that I'll have what? 1 over here. So to what? Sine nt. Okay, sine what? Nt. If I put in 1. Okay, now let me put in what? 2. If I put in 2, I'll have what? Sine 2 pi over 2. Okay, I'll have sine 2 pi over 2. Okay, sine 2 pi over 2 is basically sine what? Sine pi. Okay, sine pi. Okay, so sine pi, the value is what? 0. So that means that the whole of this one becomes what? 0. Let me put in 3. If I put in 3, I'll have what? Sine 3 pi on 2. So sine 3 pi on 2, the value is what? Minus 1. So that means that I will have minus 1 over what? 3 squared sine what? Sine nt. Okay. Let me put in 4. So I'll have sine what? 4 pi over 2. Sine 4 pi over 2 is basically sine 2. And then when I have sine 2, this place is supposed to be what? So if I put in 4, I'll have what? Sine 4 pi over 2. Sine 4 pi over 2 is basically sine what? 2 pi. If I have sine 2 pi, 2 pi is what? 0. Is 0. So that means that the whole of this one becomes 0. So it will be not defined. Let me put in 5. If I put in 5, I'll have what? Sine 5 pi over 2. Okay, so let's see sine 5 pi over 2. So 5 pi over 2. Here, this place is what? Here will become what? Sine. Here is what? 3 pi over 2. Here is what? 2 pi. So here is what? 5 pi over what? 5 pi over 2. So sine 5 pi over 2 is 1. So that means that I'll have 1 over what? 5 squared sine what? Nt. Okay. So it will go on and on and on like this. So basically, n is defined for what? 1, 3, 5, okay, 7, and on for odd numbers. Okay. So because I told you that it's an odd signal. Okay. And this is within the interval what? For which interval? The interval was what? Minus pi on 2 into what? T into what? 3 pi on what? 2. So, students, this is how you solve this question with the expansion and everything. All right. Thank you so much. See you in the next lecture. Bye-bye.